All right, let's talk about something you've probably heard thrown around if you're into electronics, the RTOS, or real-time operating system. Now, I know it sounds super technical, maybe even a little intimidating, but really, it's just a clever solution to a very, very common problem. And to get why it's so important, we've got to start with a feeling I bet you know all too well. Yeah, you know the feeling, right? You start a project, it's simple, you're just blinking an LED. Easy, then you add a button, then a sensor, maybe a little display, and before you know it, your once beautiful code is just a complete mess. Things are lagging, buttons don't seem to work half the time, and you're just about ready to throw the whole thing against the wall.
So if that little horror story sounds familiar, then you were almost definitely using something called a super loop. And look, that's what pretty much everyone starts with, and for good reason. But it's got some serious limitations once things start to get even a little bit complicated.
So yeah, let's kick things off with that. What in the world is this super loop? Well, here's the thing. If you've ever written a basic Arduino sketch, you already know exactly what it is. You've been using it all along. Okay, so the way it works is super simple, very sequential. First, your program runs some setup code one time, and then boom, it drops into this forever loop. And inside that loop, it's just ticking off a checklist, one thing after another. It does task A, then it does task B, then it does task C, and when it's done, it goes right back to the top and does it all over again. You know, read a sensor, crunch some numbers, update a screen, rinse and repeat, forever. And hey, let's be super clear here. There is absolutely nothing wrong with this approach. For a ton of simple projects, the super loop is actually the perfect choice. I mean, it's incredibly easy to get up and running, it's really light on memory and CPU power, and honestly, it's a heck of a lot easier to debug when something goes wrong. But, and you knew there was a but coming, that beautiful simplicity is also its biggest weakness. See, the super loop has a breaking point, and when you hit that breaking point, things can get real ugly, real fast. So here's the million-dollar question. What happens if one of those tasks, let's say task B, suddenly takes a really long time? Maybe it has to do a heavy calculation, or it's just stuck waiting for a slow sensor to respond. Well, you guessed it. Every single other task gets stuck waiting because it's all in a sequence, right? Task C can't even think about running until task B is totally finished, and task A can't get its next turn until C is done. The whole system just grinds to a halt, frozen, waiting for that one slow task. And this is when you start seeing those super frustrating problems in the real world. This is exactly why your display starts to feel laggy, or why you might miss some important sensor data coming in. It's why you press a button and nothing happens. It's not that the code is broken, it's just that the loop was busy doing something else when you needed it. Okay, so this is the exact moment where the RTOS steps in to save the day. You can think of it like a really, really smart traffic cop for your code, expertly managing all the different tasks that need to run. So what is an RTOS really? Well, at its heart, it's a special kind of operating system built for one main job: to schedule all your little tasks in a way that can guarantee, and that's the key word, guarantee that the most important stuff gets done on time every single time. No exceptions. Using an RTOS basically gives your project superpowers. Suddenly, you can run multiple things at what seems like the same time. You can tell the RTOS, hey, this task is way more important than that one, and it'll listen. It helps your tasks share things like memory without stepping on each other's toes. But the biggest superpower of them all is that timing guarantee. And that brings us to the most important word you'll hear when talking about an RTOS: determinism. This is the secret sauce. All it really means is that the system's behavior is totally predictable. You can know with absolute certainty which task is going to run, when it's going to run, and for how long. It's how you can be sure that the task controlling, say, an airbag in a car will fire exactly when it's supposed to, no matter what else the car's computer is doing. You know, to really nail this down, it helps to compare an RTOS to the operating system you're using right now, like on your computer or your phone. Okay, so look at something like Windows or Mac OS. We call that a general-purpose OS. Its main goal is to give you the best average experience. If your mouse stutters for a millisecond, it's no big deal, right? Its timing is unpredictable. It's non-deterministic. An RTOS is the complete opposite. Its only goal is meeting those strict timing deadlines. Forgetting to update your screen is one thing. Forgetting to fire the brakes in a car's ABS system, that's catastrophic. So you can see they're just different tools for very, very different jobs. All right, so you might be thinking, okay, I get it for cars and medical gear, but why would I ever need one for my little project? And the answer really comes down to one thing: managing modern complexity. Because here's the magic trick of an RTOS, right? It lets you do all this stuff at once. But wait a minute, most of the microcontrollers we use only have a single core. So how is it even possible for them to run multiple things at the same time?
Well, here's the secret. It's an illusion, a really convincing one. What the RTOS scheduler does is it gives each task a tiny little slice of time to run. We're talking microseconds. So it'll run task A for a split second, then it quickly saves its state, pauses it, and swaps in task B. It runs that for a split second, saves its state, and so on and so on. It switches back and forth between them so incredibly fast that to us, it looks like they're all running at the same time. It's just a brilliant trick.
And a perfect example of this in the wild is a chip like the ESP32. I mean, think about it. That little thing has to handle its Wi-Fi connection, its Bluetooth radio, read data from a bunch of sensors, respond to you pressing a button, and control a motor all at once. The only way it can pull that off without becoming a tangled mess is because it has a manager. And that manager is an RTOS, in this case, free RTOS, running right under the hood. It's the thing making all that parallel magic happen. Okay, so let's wrap this all up. What's the bottom line here? It's pretty simple, actually. Superloops, they're awesome for simple projects. Don't overcomplicate things if you don't have to. But an RTOS, that is your powerful tool for managing complexity. It's what guarantees that your critical jobs run on time, and it's what makes it possible to do all this cool concurrent stuff on even pretty simple hardware. And that really leaves us with one final question to think about. Your Superloop project might be working great today, but as you start adding more features, as your ideas get bigger, is that simple loop ready for tomorrow's complexity? Knowing when it's time to level up and bring in a tool like an RTOS, that's what separates a simple weekend project from a truly robust, scalable system. Something to think about for your next build.